So what we're going to go into for today is line segments or a segment. So a line segment or a segment is, so I'm going to go ahead and go back. And so for our definition that we had from yesterday is it's part of a line between two endpoints. So let's go ahead and go back. Part of a line in between two endpoints. Okay, so here we have congruent. So congruent is objects that have the same dimensions and shape. The congruent symbol is, and so they have this little symbol here. It's an equal sign with a little squiggly line on top. That's congruent. So here we would say the squares are congruent because they're both 3 by 3, which is an area of 9. They're the exact same squares. Okay. Congruent segments. So when we say segments are congruent, segments of the same length, congruent segments are marked with equal number of tick marks. Okay, so what that means as they put this little line here and this little line here just to tell you those two lines are the exact same size. Okay, and when you write the congruency statement, it's AB is congruent to segment CD. Next, midpoint. Midpoint means the point that is in the middle. So the point is at the exact center of the segment. So this is a midpoint right here. And so we can actually put tick marks, one here and one here, to show, well, if that's the middle, then that means that this section from here to here, whatever number this is going to be equal to this one. So if this is 2, this is also 2. Okay. The next part, segment bisector. So here we have a segment again. Bisect means to cut into 2 equal parts. So any ray segment or line that divides a segment into 2 congruent segments, it's called bisect. Bisect dividing into 2 congruent parts. So here we have a segment, and the segment is being bisected by a ray. Okay, again, we have a segment here, and this segment is being bisected by a line. And then here again, we have a segment, and it is being bisected by another segment. Okay, it's being cut into 2 equal parts. Now remember, when it's being cut into 2 equal parts, and this side is the same as this side. Okay, this little piece here is the same as this piece. So you use 2 tick marks if you're doing a separate piece that are different numbered. Okay, and then this would be equal to this. Okay, so if we look at these examples, it says name the congruent statements in this figure. So AB. So here is AB. So from here to here should be the same as here to here, from C to D. Segment TD, because it's a rectangle. Then it says from A to C. So here's A to C should be the same as B to D. And then we have A to D. So this entire length from here all the way to here, from A to D, should be congruent to the same thing from B to C. Okay. One thing that I didn't mention is the order does matter when you're writing these congruency statements. So for example, here, if I started at A and I went down, then I started at B and I went down. Okay. If I went for this congruency statement from A to B, you have to write it C to D in the same direction. Okay, and then last it says A to E is congruent to, so from here to here, do you see how they all have a tick mark? That means that they're all congruent. Remember, it's going to be in the same direction, so we have to go from C to E, and from D to E, and from B to E. So all of them going into point E. Name the midpoint of BC. So the middle of BC is point E. All right, the next one says name the congruent segments in this figure. So our congruent segments are, we have from Z to X is congruent to, and remember, we're going to go in the same direction, Y to X. And the way that we know this is because they used 1 tick mark on each of these lines, or line segments. Okay, then the next one is from Z to P. This one has 2 tick marks. So that means from Z to P, it is congruent to Y to P. From here to here. And I know this because of the 2 tick marks. Then it says name the midpoint of ZY. The point in the middle from Z to Y is point P. And then the next part says name the segment bisector of ZY. So what is a segment that's cutting the ZY in half? And that is XB. All right, so finding the lengths of a segment. So just a review of our symbols. This one is a representation of a line. Okay, and it's a line because they use the arrows on both sides. This is a representation of a ray because it has an arrow only at one end. And then AB is a segment. Now, when we don't use anything, they just say AB, the length of segment AB or the distance. Whenever they just use A and B without anything on the top, they're asking for an actual distance. So we have something called the segment addition postulate. Okay, so it says if B is in between A and C, then AB plus BC equals AC. So it might sound kind of silly, but all it's saying is that from here to here, if you add it to the distance from here to here, from B to C, when you add them together, it should give you the entire distance from A to C. Okay, that's all it's saying. So if A to B plus B to C equals AC, then B is in between A and C. So let's go ahead and do some examples here so that it makes a little bit of sense. So from D to F, okay, that is going to be equal to the measurement from D to E plus the measurement from E to F. Okay, so we know that the measurement from D to F, they want us to find, they actually have it labeled here as X equals, from D to E is going to be 90 plus from E to F is 45. So after I plug in 90 plus 45 gives us 135. So X equals 135. It doesn't give us any units on this one, like inches, centimeters, so I'm just going to leave it like that. Right, let's try the next one. So here, they want us to find from B to C. Okay, so I'm going to have to write my segment addition postulate. So from A to B, when we add it to B to C, it should equal the whole thing, which is from A all the way to C. Okay, that's my segment addition postulate. It sounds fancy, but it's super simple. So from A to B, it is 8 plus from B to C, it is Z equals from A all the way to C is 14. Okay, we are solving for section Z, which is BC. So the way that we find it is we need to get rid of this 8 that's here. We do that by subtracting 8. What I do to one side, I have to do to the other side. So 14 minus 8 gives us 6, which is Z. So Z equals 6. That means from B to C is equal to 6. Okay, the next one. This one, it gives us letters. Okay, so we're going to have to solve for letters and then figure out what our sections are. So I'm going to write my segment addition postulate. So from W to X plus from X to Y should equal the whole thing from W all the way up to Y. So it should equal W to Y. So then we plug in. From W to X, they have it labeled as 8 plus. From X to Y, they have it labeled as A plus 6 equals. And from W to Y, this is equal to 36. So we're going to have to use a little bit of our algebra skills. So if you have an A and you add another A, that is going to give us a total of 2A plus 6 equals 36. So I'm going to start solving for A by subtracting the 6 first, and we get 2A equals 30. We divide by 2, and that means A is equal to 15. Okay, but they're not asking us for A. they're asking us to find from W to X, and they're asking us to find from X to Y. So when I plug it in here, from W to X ends up being 15. And then this one is going to be 15 plus 6, which is 21. All right, the next one. So here it says from S to T is 20, so we're going to write our segment addition postulate. So from S to T plus from T to B equals the whole thing, which is S all the way to B. So from S to T is 20 plus from T to B is N equals, and then the whole thing from S to B is 2N minus 1. Okay, so we're going to go ahead and solve for N. So I'm going to move this N to the other side. So minus N, and we get 20 equals N minus 1. Then I'm going to move this one to the other side by adding, and we end up getting 20 equals, no, not 20, 21, sorry. 21 equals N. So now that we found out what N is, we're going to go ahead and plug it in. So we already know from S to T is 20. When we plug it in from T to B, we know it's 21 because N equals 21. So T to B is 21. And then when we plug it in here, 2 times 21 minus 1. So 2 times 21 is 42, minus 1 is 41. All right, the next part. So we have S to T is Y, T to U is 18, and then we have the whole thing. So I'm going to write my segment addition postulate. So ST plus from T to U equals the whole thing. So the whole thing from S all the way to U is 2Y. Oh, sorry. I got ahead of myself. SU. So then that is 2Y minus 4. I'm going to go ahead and write it now. From T to U, we have it labeled as 18. From S to T, we have it as Y. So we go ahead and solve for Y. So we're going to go ahead and subtract the Y first. And we get 18 equals Y minus 4. And then we add the 4, and we get Y equals 22. Okay, so now that we know that Y is equal to 22, we plug it in. So here it's going to equal 22. So from S to T is 22. And then when I plug it in here, 2 times 22 is 44 minus 4 gives us 40. And that's it. Okay. The next section is saying P is a midpoint of NQ. So this is a little bit different. This is not the segment addition postulate. They're telling you P is in the middle. So if P is in the middle, then that means that this side is equivalent to this side. That means they're congruent. They're equal. So because they're equal, we're going to go ahead and take 3x and set it equal to the 2x plus 4. Okay, because they're equal in measure. So I'm going to solve for x. So minus 2x minus 2x. We get x equals 4. Okay, we solve for x. So now we can go ahead and plug in. So here we're going to do 3 times 4, which gives us 12. So from N to P is 12. And then here, 2 times 4 is 8, plus 4 should give us 12. Now, if you don't get 12, if you don't get the same number twice, that means we did something wrong. Because remember, P is in the middle. So if P is in the middle, they have to be the exact same size. And then from N to Q, the whole thing, from this point all the way to the other end, we use our segment addition postulate. 12 plus 12 is 24. All right. And the last one, it says Jane has a piece of ribbon that is 48.5 centimeters long. So I'm going to draw a picture. Here is a ribbon, and it is 48.5 centimeters long. Her scrapbook, she cuts it into 2 pieces so that one piece is 4 times as long as the other. So we have one piece This, we'll call it x, and the other one we'll call it 4x because it's 4 times as long. What are the lengths of the pieces? So we're going to use our segment addition postulate. We have this section here, which is x, plus we have the other section here, which is 4x. It's 4 times as big as the other little piece, and it's equal to the whole thing, 48.5. We go ahead and add x plus 4x. That gives us 5x. Hold on, let me fix that. Sorry. 5x equals 48.5, and then our next step to solve for x is to divide by 5. So 48.5 divided by 5, let me go ahead and 48.5 divided by 5 gives us 9.7. So x equals 9.7. That means that this piece is 9.7, and this other piece is 4 times x, which is 38.8. And our units are centimeters. So the two pieces of ribbon are 9.7 centimeters and 38.8 centimeters long. And that's it. Thank you guys.